Midas Gen is more software for the building industry, so I think you already know. And I will talk about all these aspects: the product in itself, the usability, the productivity, and the reliability of the software. And I will show you a demonstration of all that. So first of all, it is a software which is practical for the engineers, because it is not only one software with analysis and design features. It's a package of several softwares. So it's one solution. And for the CAD interface, we have a package to the import of the Tekla structure and the Revit structure. We have Midas Modeler to help for the modeling of the buildings. Midas Gen, which is the main software, of course, which is here for all the analysis and the design. And also Midas D-Shop for the auto drafting module for Midas Gen. And for the data exchange, so we have direct data transfer with Tekla structures and Revit structures. And it's possible to import STAAD, MSC, Nastran, and SAP 2000 models directly into Midas Gen. And you can also import and export AutoCAD TXF format files. And what is good about Midas Gen is that it is applicable to any kind of building. So we have stadiums, power plants, hangar, airports, cranes, underground structures also can be modeled. And here you have a few examples of some famous structures which have been simulated with and analyzed and designed with Midas Gen, like the Beijing National Stadium in the 2008 Olympic in China, and a lot of other famous structures. Now, why Midas Gen is good for the engineers? Because first, it is user-friendly and it is easy to use. There's several types of menu and task pane, work tree, and all that can be used together in order to make fast analysis. And I will show you right now in a demonstration how to perform simple analysis in Midas Gen and design of concrete structure. So this is the interface of the Midas Gen. And you have on the left what is called the tree menu, and here the bar menu. So you have actually two kind of menus you can use at the same time, and you have also the menu here. So I will just open a project and show you how it works. So this is a simple first floor of a building. So here in the tree menu you have several tabs. For all the results of the analysis are stored in this tree menu. So you can see the elements. You have the beams, so and the walls elements right here. You have several materials which have been defined. So I will not show you again how to define material in a section because you can see it afterwards. And we have boundary condition has been defined already. So all this has been fixed, and only the self-weight of the building has been applied for the moment. So the first thing I will show you is how to create the slab using the AutoMesh feature. So using all the comments which are in this menu, you just go in the mesh menu, AutoMesh, and you can select directly the type of element you want, quad or triangle. Here in this small pane, you have the tools for the selection in your model. So I will just select all the elements, all the nodes and elements who are in this pane. I have to unselect first because the walls were selected. Okay. So now the area for the slab is selected, and choose the right material here and just apply, and your slab will be automatically meshed like that. Now I will do the same for the walls here. So for the walls you have to use planar elements, and I will use only quadrilateral elements. And for the selection of the walls, you can use select elements tool here. So you just tell Midas you want to select the walls, and it will select only the walls. Click on apply, and the auto mesh is also working. So you see the walls and the slab is meshed. Now maybe you cannot see here the section, so you can use this button here to activate the section. So once you activate the section here, you can view the columns and the slab. I will hide the nodes because it is okay. It's better looking like that. Now I will show you how to apply a simple pressure on this first floor. So you have a load stand here, and clicking on pressure load, you have the load case. So here in this model, 4 load cases have been defined: the dead load, the live load, the wind load on the structure, and the wind load on the structure on the y direction. So for the pressure load, it will be live load. Again, I have to select the slab. So you see, just in 2 clicks, you can select all the elements in the slab. And I will change the unit in kilonewton. So one good thing is that you can change the unit at any time. -2 kilonewton by meter square. Apply, and you see the pressure load has been applied. So now that you have applied this pressure load in the worktree, it appears here, pressure load. So you can display to view the value of this pressure load at all the nodes. Okay. So and now I will show you how you can create a building from this first floor. So now I have only one floor. You can go in the model, and there's a building feature. So it's really useful to create a full building. You can generate a building from one floor using, so just select the number of times you want to copy this floor. The distance between the floor is 3 meters here, so just choose 3, add. Here I will uncheck this option because I don't want the pressure to be copied everywhere. Apply. Yes, so I have to select first. And now you see in just a few clicks I generated my building. So now on this building model, I will use again the tool here for the story generation. So Midas Gen has also a tool to auto-generate the story data, so it's very useful. Just click on auto-generate, and it will generate automatically all the floors. Now that all that is done, I will just launch the analysis of this model. So perform analysis. Now the solver is running and will give you the results in a few seconds. So Midas Gen solver is using a multi-frontal solver, so it's quite fast. So you saw only 10 seconds. It completed the static analysis of the building. And now you can check the results in the results tab here. So first of all, you can check the reaction. So let's say the reaction for the dead load, value, apply. And now you have the reaction here at the foot of the building with all the values of this reaction and the maximum here in red. Now what I will do is a combination of the loads after analysis. So Midas Gen can create also a combination for several types of designs. So here it is concrete material, so I will do concrete design. And a very useful feature is the auto-generation of these cases. So following the design code, so here you have the choice in all these codes. So we'll just use Eurocode for concrete and click on OK. And several loads have been defined following the steps. Yes, I forgot to show you how to define the wind load and the seismic load. So I will come back to the pre-post by clicking here and define again these loads. So to define the wind loads, you can go here in lateral loads and click on wind load. Add. So the first one is WX. So it's here you have all the coefficients to define this load. So it's in X direction. So we'll put 0 in this direction and you can just click on apply. You have the wind load profile. So depending on distribution of the shear on the story. So the story shear here. So you can choose which distribution you want. Apply. And I will create also, so here you can choose also Eurocode. Okay. 0 and 1. Okay. So for the first one, I will modify it to use Eurocode. Okay. And also you have response spectrum analysis data. So I will add also response spectrum because as you told me last time, the seismic analysis is quite important in your country. I will show you the database of seismic and design spectrum. So you click here on design spectrum and choose the Eurocode 2004. You can enter the parameters of your design. Click on OK, and your spectrum will be created automatically. So you don't need to know all these data. All that is included in the database. And to create the load cases for this response spectrum, RX, okay, using the Eurocode, add, ly. You can add some eigenvalue analysis control, so you can define the number of frequencies for the eigenvalue. Okay, now I have to do again the analysis. So we'll perform again the analysis. So it's also interesting because you can always come back and to the pre-post after doing the analysis. You can add some loads, you can modify the conditions. So this time the analysis is taking a bit more time because of the load spectrum data. Eccentricity, yes, you can add this. There's an option to define the eccentricity for it. So, yeah. There's actually two kinds of loads. One is the static seismic load, and one is the one I showed you, the response spectrum. So if you create this static seismic load, so we just finished the analysis. So here, I think, yes, you can define the accidental eccentricity here in x direction, y direction. And you can also use the Eurocode 8 for this kind of analysis. Okay, now I will show you the results again. So I've shown you the displacements. I will generate again the load combination because it didn't take in account the wind load and the response spectrum. So add, okay, and now you see it's defined much more load combination using also wind load. Okay, so let's see the deformed shape of the building. So I can choose this load combination, for example. Let's choose value. Okay. So now you have the deformation due to this combination loads. Maybe it's better to see the displacement control. So here you have displacement control on building. Now I will show you also the beam forces and the moments. No, sorry, the beam diagram for MY. Okay, line. So you have access to the beam diagram like that. All the beams. You can use a solid fill also to view it a bit better. And you can view the forces. Okay. Now I will show you how to make. Oh, sorry. I will show you also the stress because it's quite interesting to see the stress on the slab. Okay. So this is the stress control. And after this, I will show you all the tools to design this building. So after you have viewed all the results, you can go in the next step, which is the design step. So first of all, I will reset the view. So the first step is to define the code you will use. So here in design code for concrete. So you have all these codes available. Usually the Eurocode it's used in Europe. And the national index, we have Italy and all the annexes. So click on OK, and partial safety factors for the material properties. So if you update it by the code. Okay. Now, what is interesting to see is the rebar data for the columns, for example, or the beams inside your model. So by selecting the rebar, it is possible to view the state of all the columns inside the building, and in this window you can change the number of bar inside. So if you change that, it will add some bar inside. So it is possible to do the design of your building using the rebar. And now I'll show you the beam design. So it now yes. Yes, I forgot to assign the rebar. So now the solver is calculating the new design with the rebar you just defined in the beam, in the column. And in this window you can check the design for each member. So you have several ways to check. You can use select some members, and you have a graphic view of the data units, so the bending moment capacity, the shear capacity. You can view these data in more details in text format. So here it will give you the equations and the results. And now let me show you the slab design. So first of all, I will just activate the roof of this building. So story, so you can activate only the roof. Okay. And design, we have mesh slab and wall design. First of all, I will show you the rebar. So a lot of red, so it means that you need to put a lot of rebar in it. Now the wood armor moment. and you can do the design flows also. So in tab format, all the results are in tab, depending on the different load cases, load combinations, and it's possible to export these results directly into Excel format to process it maybe more in detail. Okay, it's oh yeah, I will also show you last thing, the slab shear checking. So it is possible to check the shear in your slab. So it will appear like that. So the small colors will give you the value of the shear at all these intersections, and the stress is expressed on these red segments. Okay, now let's come back to the PPT and talk about the other features. So as you saw in Midas Gen, we have a lot of useful features for the building generation and the checking of all the kind of design, the beam, the column, the slab. You can use shear wall elements, beam end elements, all kind of elements are supported. So any kind of nonlinear elements too, of course. Now, as I told you at the beginning, it's all-in-one design feature. You can design beams, columns, slab, wall, and footing. There's automatic load combination and the design results, so in function of the code. Optimal steep design. The international building codes are included. So actually, for the Euro code is included in the reinforced concrete design, the steel design, and the slab design. The solvers are fast and powerful. So the analysis is going fast for any kind of analysis. So construction stage analysis, boundary nonlinear analysis, girder analysis, or pushover analysis. You have also a lot of powerful graphics to view your model after modeling. So the rendering effects, the flying view, so you can view as if you were in front of your building, and it's good to take a screen capture of your work. Various form of graphic output, the beam displacement control, the form Midas stress, solid displacement, the stress results. This is the ISO surface, so if you want to check the stress, solid stress on this particular section or a 3D model. And also very useful thing is the dynamic report generation, which will help you to generate automatically a report with all the information you need for your analysis. So everything will be included, and when you modify it inside Midas Gen, the report will be modified automatically. So it's really useful. You make it at the beginning of your work, and afterwards it will be updated. Now Midas Gen has also a lot of high-end features, like the pushover analysis, the base isolators and the dampers, the fiber analysis, various type of mass and seismic design, and construction stage analysis. So what is really good is that you can take in account the construction stage and the time-dependent material at the same time. So the creep and the shrinkage can be considered with the construction stages. So it is very useful, particularly for the high-rise buildings. So this is why Midas Gen is mainly used for the highest buildings in the world. Nonlinear analysis. So nonlinear analysis for masonry and old buildings renovation. So I think it is good for you because in Greece there's a lot of old buildings which need this kind of masonry analysis. Yes, yes. We always build software for the future, but we never think about the buildings. Yeah. Actually, in Europe, there's more old buildings than new ones. Let me show you last demonstration. So I will show you how to make very easily the pushover analysis. So this is a very simple model. So in 2 dimensions, composed of beam, walls, and columns. And Midas Gen has the task pane, so it is a very useful wizard. No, it's not really a wizard, it's a pane which helps you to make difficult analysis. So you can see here you have pushover analysis, nonlinear time history analysis, and material nonlinear. So for the pushover, it will directly tell you the steps you have to follow. So here I already assigned all that, so I will open another project. Okay, it's the same. Okay, so you see, when it's like that, you just have to follow these steps and afterwards perform the pushover analysis, and it will be done. So the first step is to define the pushover global control. So define some load cases, so that adds dead load, live load. Okay. Now the pushover load cases. So you have possibility to increase the increment, consider P delta effect, and in this case you have several load types. So you can use static load case, uniform acceleration, the mode shape, or normalized mode shape by the mass. So I will add one like that, and another one will be uniform acceleration. Okay, so I defined 2 load cases. Now you have to define the pushover hinge properties. So you have to define it for each type of element. So first of all, for the beam. Okay, so it will depend on, so the components properties are Fz and My. You can check these properties here. So the curve can be auto-calculated, or you can also use a user input if you want to input your own data. Same for the moments. So apply. Now I will add the column. Okay. Here you can check off the yield surface property. And finally the wall. Okay. Now what you have to do is to assign these pushover hinge properties to your elements in the model. So first of all I will assign the beam and the columns. So I will select the columns using this tool, and visit the beam, apply. You have also another way to do that. You can go in the work tree, and if you double click on the material, you can directly drag and drop the hinge property on your model, so it is more easy to understand which type of elements. And when the property is not assigned, it is in blue, so you can see which property you didn't assign to your model. Now that all that is over, you can perform the pushover analysis, and all that will be. To gain a bit more time, I will just open a project in which all that has already been computed. So now you can view the pushover curve. For the target displacement in function of the code. The pushover graph, the story graph, the hinge status table. So you have all the results in table 2. This one. Yes, the hinge status results. Hinge status results. So here you can view the status of yielding legend line for y. Okay. So if it's in red, it will fail. So what you have to do is to add some rebar to make it stronger. You can view, of course, the displacement, model inclusion time. So this is after analysis. Your building will move like that. It's possible to view the animation too. It's possible to accelerate the animation and to save it directly. So you can save the animation in a video format, and afterwards you can put it in your report. Okay, so as you saw, it's complicated analysis, but using this task pane, it will give you exactly the steps you have to follow to do the analysis. So it is easy to understand how to do this kind of analysis. Now, finally, last thing, the service. In Midas, we always give you the best service, so we will provide notice, updates, and we have an official upgrade every year for the software. So we have a big, let's say a big update every year, and some smaller updates every 3 months or 6 months, depending on the product. We can customize in function of the market. So if your country requires a certain type of design code or something, it is always possible to customize. We provide lots of online training. So we have free online training on internet, webinars like today. and also in-house courses. On our website we have a lot of tutorials, and we organize also some seminars and workshops in different countries to present to customers the product. And we have some technical papers too. So technical papers, seminars, workshop, all that. We already organized a lot in a lot of countries. I cannot tell you the number, but in Europe, a lot of countries we organize seminar almost 1 or 2 times per year. And finally, what you have with Midas Gen is also the reliability, because various project applications, a lot of very famous buildings have been constructed using Midas Gen, and a lot of companies in the world are clients of Midas. Okay, and we provide also some verification examples if you want to check on the error code, so more than 100 verification examples and design verification examples. Okay, it's all for the presentation, so right now we'll go to the question step. So actually I'm with Rabi, which is a senior engineer in structure analysis at Midas Gen, so he will be here to answer your question.